All right, so this is our video notes on polarity. This is page 7 of the packet, so if you are not on page 7 right now, your page probably doesn't look like this. So follow along on your page 7 as we go through this. So right off the bat, this word polarity might be unfamiliar to you. Polarity is just our fancy science way of saying that something is magnetic. Okay. So just as a little review from physics, we know that same charges, if we had like a positive and a positive, these are going to repel each other. And then the very common phrase opposites attract, when we've got one side is positive, the other side is negative, these are going to attract. So that's the basics of magnetism, but we're going to see what that actually means for our bonds. So last time we learned about our two different types of bonds. We had ionic and covalent bonds. In this case, all ionic bonds are polar, meaning they are all magnetic. And some covalent bonds are polar, but other covalent bonds are going to be non-polar. So the gist here, all ionic bonds are polar, but only some covalent bonds are. And we'll take a look in just a second about how we can tell the difference between these. So for our first one here, let's do this example together. Sodium is a metal. So I'm going to put metal above sodium. Chlorine is a nonmetal, so that's a non. And remember, when we have one is metal, one is nonmetal, that always means it's an ionic bond. And so this is actually ionic, which is always polar. So I'm going to say it's ionic polar. Okay. Next one down, hydrogen is a nonmetal, and oxygen is a nonmetal. So thinking back to those notes we did last time, when we have two nonmetals, that is a covalent bond. And in this case, H2O, water, is a polar covalent bond. And we're actually going to do exactly why that is in an example towards the bottom of the page. And then our last one, H2. H is a nonmetal, and it's bonded with itself. That's what the H2 means. So this is a non-polar covalent bond. Okay. We're going to kind of do a little side note here. So this H2 is called a diatom because it's got two H's bonded together. All diatoms are nonpolar covalent. And what I mean by diatom is things like the H2 that we see here. It could be Br2, I2, N2, O2. Any nonmetal that has a little 2 next to it is a diatom. And so whenever you see this in a problem, you can immediately know that it is a nonpolar covalent bond. So let's talk about how we know that these are polar or nonpolar. We're going to be learning a new chart called the electronegativity chart. Electronegativity is the ability of one atom in a compound to attract more of the electrons. The periodic trend, so how the numbers go on the periodic table, and we can see it down here, it's going to increase from the bottom to the top. And we can see that in the table. As we go from bottom to top, you can see that the numbers are getting bigger. So I'm going to label that on my table here. You can see that it increases going up. And then it's also going to increase as we go from left to right. So as we go across the table to the right, we see that it's also increasing. So I'm going to show my arrows that it's increasing this way. So this was mostly definition stuff. Let's look at an actual example of a problem that you'll get on a test about this. So down below here, we've got a few different examples of electronegativity differences. So for our first one here, we've got H and O. And so what we're going to do is take our value for H. We need to find it on our table here. In this case, H is at the top left. It's got a number of 2.1. So H is 2.1. And difference always means subtraction. So we're going to take our number for H and subtract our number for O. O has a number of 3.5. And so we'll get 2.1 minus 3.5. The last thing that we really need to know here is that there are no negative numbers. So if you get a negative value, just remember that it's always going to be a positive. So we've got 2.1 minus 3.5, and that's going to give us negative 1.4. But since I know that there's no negative numbers, I'm just going to ignore that negative, and I know that it's just 1.4. So we found this 1.4. Now what does that mean? On your page, there is this chart in the bottom left, and it gives us the ranges for each type of bond. So anything from this 1.7 to 3.3 is going to be an ionic bond. Anything from 1.7 to 0.3 is polar covalent, and then anything from 0.3 to 0 is nonpolar covalent. And so if we were to take our number 1.4 and figure out where it goes in the chart, it's going to be somewhere in this middle range, which means it is a polar covalent bond. So 1.4 polar covalent. And I'll box that because that would be our final answer. It is a polar covalent bond. Let's try the next one as well here. So here we've got 2.1 minus 2.1 because it's hydrogen minus hydrogen. This is actually a diatom. This would be H2. And so you'll see that when we do 2.1 minus 2.1, we get a value of 0. There's no electronegativity difference because it's the same atom. And so on our chart, 0 means it's nonpolar covalent. Nonpolar covalent. And that is why all of our diatoms are a nonpolar covalent bond. There we go. All right, and our third example here, we've got NaCl. So Na has a value of 0.9. And we are subtracting Cl, which has a value of 3.0. 0.9 minus 3.0 will give us our answer here. When I plug that in, I'm getting a negative 2.1, but once again, ignore the negative. So it's just a 2.1 for our difference. And if I look at my chart, 2.1 is actually going to fit in that top section. So I know that this is an ionic bond. And remember, all ionic bonds are polar. We'll box that as our answer. So what I want you guys to do is take a second to do this bottom part on your own. So pause the video right now, try this section, and then check your answers afterwards to see how you did. All right, and here are the answers. Go ahead and check your work. Make sure that you got the correct answers. If you did not, correct it on your page so that you know what the correct answer is. If you have any questions about this type of problem, now would be the time to call me over for some help on it. Once you are done with page 7 for the notes, you can move on to page 8. So on the next page, zoom out here. Page 8, this is exactly like what we just did in the notes. So each chemical formula, you need to find the electronegativity difference and then determine what the bond type is. The only thing you need to change is this table at the top has a typo. Instead of 0.5, this should be 0.3. So using this table and the periodic table on the back that shows the electronegativity values, you can complete this page. There are 3 questions at the bottom for you to do as well. Once you're done with this page, you will get a stamp, so call me over if you have any questions or if you are finished.